Okay, students, this is Physics Class 10 National Book Foundation, Unit number 13. Topic is electrostatics, and we are doing exercise containing multiple choice questions. Question 1 is how many electrons form 1 coulomb charge? I'll solve this using one very simple example. If you need to find mass of 10 books, with each book having mass of 2 kg, how you do it? You multiply 2 kgs with the number of books to find 20 kgs total mass. Just like that, if you have the charge on one electron, that is E, you have a couple of electrons, say number n, the total charge on the n electrons will be equal to E multiplied by n, or simply you can write n times E is equal to Q charge. Now, if you need to calculate for a number of electrons, what you need to do is move E to the right side. And since it is multiplication here, on the right side it will be divided, and Q is divided by E. Substitute Q is equal to 1 coulomb. E is equal to 1.6 into 10 power minus 19 coulombs per electron, and this is the value that you need to remember. You need to learn this by heart. Calculating this using a calculator, maybe you get 6.25 into 10 power 18 electrons. So the correct answer is 6.25 into 10 power 18 electrons. Question 2 is what is the electrostatic force between two charges each of 1 millicoulombs separated by a distance of 1 meter? Now, the given is two identical charges each of 1 millicoulombs, that is Q1 is equal to Q2 is equal to 1 into 10 power minus 3. 10 power minus 3 is millicoulombs. The distance R between the two charges is 1 meter. The value of K you know is 9 into 10 power 9 newtons meter square per coulomb square. Now use formula for electrostatic force. F is equal to K Q1 Q2 over R square. Now substituting these values, K is equal to 9 into 10 power 9, the charge is 1 into 10 power minus 3, 1 into 10 power minus 3 divided by 1 meter square. This results in 9,000 Newton. Now this 9,000 Newton you can even calculate without the calculator, because 10 power minus 3 into 10 power minus 3 makes it 10 power minus 6, adding the two exponents. Now 10 power minus 9 minus 10 power minus 6 results in 10 power 3, and 10 power 3 is 3 zeros. Just put 3 zeros in front of the 9 because the denominator is 1 and that will keep it 9,000. So it is simply 9,000 Newton. The correct answer is 9,000 newtons. Question 3 is if the distance between charges is doubled, then the force between them becomes. Now, recall that electrostatic force between two charges is given as F is equal to K Q1 Q2 over R square, where Q1 and Q2 are the two charges in coulombs, R is the distance between them in meters, and K is the coulomb's constant. Mark this as equation 1. Now, doubling the distance means new distance R dash becomes 2R. Then the new force becomes F dash is equal to K Q1 Q2 over 2R square. Now, squaring the denominator results in F dash is equal to K Q1 Q2 over 4R square. Now, separate this 4 from K Q1 Q2 over R square and write it as F dash is equal to 1 by 4 K Q1 Q2 over R square. Now, replacing K Q1 Q2 over R square equal to F from equation 1 results in F dash the new force equal to 1 by 4 of the original force. So the correct answer here is 1/4. Question 4 is, if a test charge of 2 coulomb experiences force of 10 Newton in an electric field of 5 coulomb charge, the electric field intensity at that point is, now note that there is an electric field of 5 coulomb charge, there is a test charge of 2 coulomb at some point where the force calculated in this field is 10 Newton. Now, using the formula for electric field intensity, E is equal to F divided by Q test charge, Q naught. Substituting the values 10 Newton for the force, 2 coulomb for the test charge results in 5 Newton per coulomb. So the correct answer is 5 Newton per coulomb. Now here, note that this 5 coulomb is the source charge. The force of 10 Newton has been calculated with the source charge at that point. Now only the test charge of 2 coulomb is used for finding the intensity. Question 5. If the potential difference between plates of capacitors is reduced to half, then capacitance of the capacitor becomes. Note that capacitance of a capacitor is a constant and depends on the physical properties of the capacitor. The physical properties are area and geometry of plates, medium used between the plates, and the distance between the plates. Capacitance has nothing to do with the voltage, therefore the capacitance remains constant. Moreover, remember that charge is directly proportional to V. Therefore, reducing the potential difference V to half will reduce the amount of charge Q to half. Question number 6. Farad is the unit of, by definition, Farad is the unit of capacitance. So, the answer is capacitance. Question 7. If two capacitors are connected in series, then the capacitance of the combination becomes. In series combination, the net capacitance is always less than any of the capacitors involved. That means less than the least value capacitor. The answer is net capacitance of series combination decreases. Question 8. Which is a vector quantity? Electric field intensity is E is equal to F divided by Q, that is, force is a vector and charge Q is a scalar quantity. A vector quantity divided by a scalar quantity always remains a vector. Therefore, the answer is electric field intensity is a vector quantity. Question 9. If a capacitor stores charge of 10 coulomb when potential difference of 5 volt is applied, what will be charge on capacitor if 20 volt are applied on it? Now, to solve this question, if you can recall chapter 3, variations of mathematics, class 10. The equation given here is Q is equal to CV, where Q is the charge, C is the constant of proportionality, capacitance of the capacitor, and V is the voltage applied. Solving for C with the given value of 10 coulomb and 5 volt, equation 1 becomes C is equal to Q over V. Substituting Q is equal to 10, V is equal to 5 to calculate C. C is equal to 10 divided by 5 equal to 2 farad. Now, using C equal to 2, equation 1 becomes Q is equal to 2V. Now, use V is equal to 20 to calculate Q. Since it is given that V is equal to calculate charge on the capacitor, if 20 volts are applied on it, With C now calculated as 2, Q is equal to 2V. Substitute V is equal to 20. So Q is equal to 2 into 20. That means Q is equal to 40 coulombs. So the answer is 40 coulombs. Question 10. Which of the following is touched with disc of charged electroscope but gold leaves of the electroscope do not collapse? Touching the disc of a charged electroscope with a conductor will remove any excess charge, positive or negative, hence neutralizing the electroscope, causing its leaves to collapse. Only a paper rod is a non-conductor which will not affect the leaves of the electroscope. The correct answer is paper rod.